Hi, it's Dr. Weideman, and I'm going to show you how to use StatCrunch to work some problems in Chapter 18. We'll do one problem where we have the data and one problem where we simply have a summary. So the first problem we're going to do is from your textbook, problem number 41. This gentleman was interested in finding the optimum combination of power and time to deliver high-quality popcorn with less than 10% of the kernels unpopped. After he experimented with several bags, he determined that power number 9 for 4 minutes was the best combination. To ensure the method was successful, he popped 8 more bags of popcorn selected at random at this setting. All were high quality with the following percentages of uncooked popcorn. Does this provide evidence that he met his goal of less than 10%? So the first thing we want to take a look at is what are going to be the hypotheses, and also we're going to need to check our assumptions and conditions. So the hypotheses are going to be, the null is going to be that the mean is 10, and the alternative is his goal was to get less than 10%. Assumptions and conditions, it said in the problem that the bags were randomly selected, so it's reasonable to assume they're independent. 8 bags is certainly less than 10% of all popcorn bags, and the nearly normal we're going to check by using a histogram. So I'm going to go ahead and in here just click on the StatCrunch tool, and I've already got it opened up here. Here's the uncooked popcorn that he found, and we're going to go ahead and we're going to do a histogram. Select the data, compute. Now my histogram doesn't look too continuous. I'm going to just do a little change here and change the bin width from 2 to 3. Sometimes when you don't have a lot of data, we only have 8 here, it's better to have a little bit wider intervals. So this looks unimodal and fairly symmetric. No significant skewness or outliers. So I think we're good to go. So now the technique that we're going to use in here when we have the raw data is stat, t-statistics, one sample with the data. So we're going to select the unpopped popcorn as our variable. The null, remember, was 10, and the alternative was that it was less than 10. And we'll go ahead and hit compute. And so here's our results. We see that our standard deviation 1.29, the t-statistic was negative 2.5, and the p-value, if we were testing at 0.05, we would reject the null and say that yes, indeed, he has shown that the average unpopped kernels is less than 10%, so he met his goal in this particular problem. We could also from this window do a confidence interval, go back and edit and select instead of the hypothesis test the confidence interval. And so we're 95% confident that on average between 3.7 and about 9.8% of the kernels will be unpopped. Notice the interval extends just below 10. It doesn't go over 10, so that supports our hypothesis test. Okay, let's go back and let's work a problem where we only have summary data. So hoping to lure more shoppers downtown, a city builds a public parking garage in the central business district. The city plans to pay for the structure through parking fees. For a random sample of 42 days, daily fees collected averaged $125 with a $16 standard deviation. Can calculate a 99% confidence interval for the mean daily income. So we're going to go ahead and go over to StatCrunch, and we can just click on data sets. We really just need to get a blank worksheet. And so we're going to do a confidence interval, so we're going to go stat, t-statistics, one sample, and now we have a summary. Remember, it was $125 average, the standard deviation was 16, and the sample size was 42 days, and they asked us to do a 99% confidence interval, so we're going to go ahead and change the 95 to 99. So I'm 99% confident that the average daily income from the parking garage ranges from $118 up to $132. Now let's say that the city manager believes that if the mean daily fee income exceeds $120 in the parking garage, then the parking garage can be paid for in 1 year. Test the hypothesis that the mean daily fee income exceeds $120, use alpha of 0.05, and we're going to assume that the assumptions and conditions are met. So my null hypothesis is going to be that the mean is 120, and the alternative is that we want it to exceed 120. So let's go back. We can actually just edit the window that we use for the confidence interval, and we're going to do a hypothesis test now. And we want it to be 120, the null, or greater than 120, and hit compute. And so using an alpha of 0.05, our t-statistic is a little bit greater than 2. And so we see that the p-value is 0.025, which is less than 0.05, so therefore we would reject And we would say that yes, indeed, it does appear that the mean daily income does exceed $120.